All right, guys, today we're going to start with a review on the laws of conservation of matter and mass. So both of those laws have to do with what we've been talking about, atoms and elements, and all of those things are represented in our world by how they're constantly combining. And those things combine in a way called a chemical reaction. And chemical reactions are where you have reactants that combine and they form a new product. You may have seen this in your life when you are baking something, for example. So when you bake a cake, you start with all of your ingredients, and then after you have your ingredients, you end up with a new product, just like this. So to bake your cake, you start with your eggs, your sugar, your flour, your butter, your vanilla, your salt. Then you mix it all together, you put it in the oven. Hint, heat is typically one of the precursors to get a chemical reaction to occur if it won't do it naturally. And then you end up with cake. So the things you start with are called the reactants, and the things you end with are called the products, like I have written here. So your reactants are the stuff you start with your cake, and your products are the things or the thing that is made through that reaction. Now, chemical reactions are represented by atoms in chemical equations. So for example, we have 2Na plus Cl2 yields, that's the arrow sign, and arrow didn't look right, so I put those couple carets there, 2NaCl. Now, in a chemical equation, you have different elements. Na is sodium, Cl is chlorine, and they form something, NaCl, which is commonly known as table salt. When you look at a chemical equation, a capital letter starts a new element. So if Na is the atomic symbol, like we learned last week, the A must be lowercase. Cl, C is chlorine, the C is capitalized, and the L is lowercase. So you can always tell when it's a different element by the new capital letter. Same thing here. We have P4O10 plus 6H2O yields 4H3PO4. Now, the little number, that's called the subscript. The little number tells you how many atoms of that element there are. So for example, there are 4 phosphorus atoms here. There are 10 oxygen atoms here. The coefficient in the front, that's kind of like the distributive property. It tells you how many groups or how many molecules. So in this case, I have 6 molecules of H2O. So how many total atoms of hydrogen I would have? 6 times 2 means 12 hydrogen atoms, and 6 times this invisible 1 would be 6 oxygen atoms. And then this says 4H3, which means I have 4 times 3, 12 hydrogen atoms, 4 times the invisible 1 on the P, 4 phosphorus atoms, and 4 times 4, the subscript on the oxygen means 16 oxygen atoms. So the subscript tells you how many atoms, and the coefficient tells you how many molecules or groups of something you have. Now let's go to your gizmo, and we're going to do one of the examples in your gizmo that you did yesterday, and we're going to focus on the law of conservation of matter. So your gizmo told you to set it up with H2 plus O2 yields H2O. So one of the questions it asks is how many reactants and products there are. So I see 2 hydrogen atoms as reactants, and I see 2 hydrogen atoms as products. I see 3 oxygen atoms as reactants and 1 oxygen atom as a product. Now, the law of conservation of matter says that it must be balanced in order for it to make sense or be met. So in this case, you need the same number of atoms of each element on the reactant side as you do on the product side. So let's look to see if that's true. There's 2 hydrogens as reactants and 2 hydrogens as products. That means that the hydrogen aren't balanced. However, there are 3 oxygen atoms as reactants and only 1 oxygen atom as a product. So if I look at that, I see that the law of conservation of matter is not being met here. What that means, though, is that basically this reaction wouldn't happen. So when I go ahead and I balance it, like my gizmo tells me to do here, and this is what I will see, I put a 2 in front of the H2 and a 2 in front of the H2O on the products. I get 4 hydrogens as reactants, 4 hydrogens as products, 2 oxygens as reactants and 2 oxygens as products. What this means is that if I started with 2 molecules, each with 2 hydrogens in them, and 1 molecule with 2 oxygens bonded together, and I put them together, they would magically create 2 water molecules. So now my law of conservation of matter is supported, followed, or met, however you want to state that. You have the same number of each element as both reactants and products. 4 hydrogen, 2 oxygen, 2 oxygen. Now your gizmo is also asking you about the law of conservation of mass. The law of conservation of mass is just like the law of conservation of matter, you just swap the word mass in for matter. The law of conservation of mass says mass can't be created or destroyed, only conserved. Conserved means it stays the same. So let's look at our ending product. This is our balanced equation. Now, each hydrogen atom, according to the periodic table, like we saw last week, says each hydrogen atom is 1 atomic mass unit in weight. That's its average atomic mass. So for every hydrogen, it weighs 1 atomic mass unit. For every oxygen, it weighs about 16 atomic mass units. So if I want to see if it follows the law of conservation of mass, I have to figure out what is the mass. So for hydrogen, I have 4 of them. 1 atomic mass unit times 4 atoms equals 4 atomic mass units. Now for my oxygen, I have 2 of them, and that is 16 atomic mass unit times the 2 atoms equals 32 atomic mass unit. So that's what I see on my reactant side. So on my reactant side, I see that hydrogen's mass is 4 and oxygen's mass is 32. Total, they equal 32 plus 4 is 36 atomic mass units. Now let's look over here. On my product side, I have hydrogen. Oops, let's move this over here. I have 4 hydrogens, and they're each 1 atomic mass unit times 4 atoms equals 4 atomic mass units total. And then for oxygen, I have 2 of those, and those are 16 atomic mass units times 2 atoms equals 32 atomic mass units. So on my right side, or my product side, I have the same exact thing, which means my total is also going to be 36 atomic mass units. Now, what is interesting here is that if your equation meets the law of conservation of matter, meaning you have the same number of atoms of each element as reactants and as products like we do here, the law of conservation of mass will always be met. It's not possible for you to have more or less mass than you started with. Let's look at one of the other examples on Gizmo. So they wanted us to type CaOH2. So now we're bringing in some parentheses. So let's do this, CaOH2. Now the question was, what does that parentheses do? So what that parentheses does is called a subscript. The little numbers are called subscripts. They are not exponents. What that parentheses does is it multiplies that number times each of the atoms on the inside. So if I look at CaOH2, I know that I still only have 1 Ca. The parentheses, or the number outside the parentheses, does not affect anything that is not in the parentheses. So it doesn't affect the Ca. I have 1 Ca, and then it multiplies the 2 times the H and the 2 times the O. So I have 2 O's and 2 H's. Let's try if I do it with the 3. Multiply the H times 3, 3 H's. Multiplied the 3 times the O, I have 3 O's. It'll do the same thing if I do 4. If I put a subscript in there, it would also do 4 times 2. So now I have H, O's in here. If I made this a 3, I will now have 12 O's, and so forth. Now, let's look at this equation. Let me type this in real quick. CaOH2 plus HBr, and then CaBr2 plus H2O. This was also on your Gizmo. So now I'm looking at this for what it is, and I see that it is not balanced. I see I have 1 Br as reactants, I have 2 Brs as products. I have 1 calcium as a reactant and 1 calcium as a product, so calcium's balanced. I have 3 hydrogens as reactants, 2 hydrogens as products, not balanced, 2 oxygen as reactants, 1 oxygen as a product, so it is not balanced. So your gizmo told you to balance it by messing with the HBr and the H2O. So I put a 2 in front. Remember, those are called coefficients, and they multiply. So here I have 2 Brs, 2 Brs, 1 Ca, 1 Ca, 4 Hs, 4 Hs, 2 Os, 2 Os. Now I know that this is balanced. So let's look here. You can see that this is balanced. That's just a screen grab of what we had in front of us. So now let's figure out if the law of conservation of mass is met. Remember, if the law of conservation of matter is met, then the law of conservation of mass is met. But you might need to prove it, which is what it wanted you to do here. So I know my hydrogen. I have 4 of them, and I have 4 atoms times 1 atomic mass unit equals 4 atomic mass unit. Now for my oxygen, I have 2 of them, and there's 2 atoms times 16. I got that from right here, my atomic mass of oxygen. 16 atomic mass units equals 32 atomic mass units. For my bromine, I have 2 of those, so 2 atoms times now about 80 atomic mass units equals 160 atomic mass units. And for calcium, I have 1 of those at about 40 atomic mass units. That means I have 40 atomic mass units there. So now if I total all these up, 40 plus 160 is 200, plus 32 is 232, plus 4 is 236. So my total mass of my reactants is 236 atomic mass units. Now I could do all of this math again, but if I look at my products, my reactants and my products are exactly the same. So what that means is I started with 236 atomic mass units. I started with 2 Br, 1 Ca, 4 hydrogen, 2 oxygen, and I end with 2 Br, 1 Ca, 4 hydrogen, 2 oxygen, which means it weighs 236 atomic mass units. Remember, if something follows the law of conservation of matter, it'll only do that if it's balanced, and once it's balanced, it will also follow the law of conservation of mass if you do the math. Now, go ahead and please take out your IMB and turn to your WWK pages, and we'll write down a couple WWKs. The first WWK is reactant. So the reactant, again, is the starting materials of a chemical reaction. Pause the video and please write this down. The second WWK is a product. A product is the ending or the form substance of a chemical reaction. Please pause the video and write this down in your IMB. The third WWK is the law of conservation of matter. What that states is matter cannot be created or destroyed, only transformed. I like to think of this as kind of like Legos. So you start with all these Legos in a bag, and then you follow the rule book, and then you end up with a different product. You didn't create or transform or destroy anything. You only transformed it into a different product. Just like your cake, you're taking what you have, you're rearranging it to form something new, even though it's still made of the same stuff. Go ahead and pause your video and write this down, please. The last one is the law of conservation of mass. That states that mass cannot be created or destroyed, only conserved, which means remains constant. Please pause your video and write that down. Now turn to your key concept pages and we'll write down these couple key concepts. The first key concept says all chemical equations are made of reactants. Those are the starting or the things on the left side of an equation, and products, which are the ending things or the things on the right side of the equation. Please pause the video and write that down. The second key concept is in order for a chemical reaction to occur, the reactants and products must be balanced. If they are not balanced, the reaction will not occur. Please pause the video and write that down. And the third one says, if balanced, all chemical reactions will follow the law of conservation of matter and mass. It is impossible to create or destroy matter or mass. Please pause the video and write that down. So the whole purpose was for you to see that in order for chemical reactions to occur, you have to have the same number of atoms as reactants as you do as products. Once you have them equal on each side, you will have a balanced chemical equation. Balanced chemical equations are the ones that will happen either readily, so on their own, or with some type of outside impact. For example, sometimes you put baking soda in vinegar and it doesn't fizz. But if you put a lot of baking soda in vinegar, it will fizz. So that kind of goes to that balance thing. You need a certain amount for things to happen. You could have a single oxygen atom and a single hydrogen atom, but they're not going to form water. You're going to need them in that specific balance in order for them to occur. If you have any questions, please feel free to reach out and ask us. Thank you.